Now we start discussing all about the trigonometric functions. In the previous standard, trigonometric ratios you told. Trigonometric ratios, trigonometric functions are one and the same. But you may think what exactly when trigonometric functions, when trigonometric ratios. Practically that you know the ratios of two sides of a right angled triangle called trigonometric functions. Ratios of two sides of a right angled triangle. When that angle is considered in radians, so we use trigonometric functions. Especially when the angle is considered in a radian measure, instead of trigonometric ratios, we use trigonometric functions. Okay, but now whether you use it trigonometric ratios or trigonometric functions, and both are one and the same. Now, I am not going to repeat the trigonometric definitions and what are the basic identities, but I want to explain those trigonometric functions in other sense. But you have already understood that what is sin x, what is cos x, what is tan x, and cosec x, sec x, cot x. There are 6 trigonometric functions. But now I am not going to explain that sin x is equal to opposite by hypotenuse, cos x is equal to adjacent side divided by hypotenuse. I am going to define in some other way that you remember for easiest way of understanding the concept of trigonometry. So what is the easiest way? Suppose I consider one unit circle. Unit circle means already I have told you whose radius is 1 unit. This is taken as unit circle. Try to understand. Unit circle is nothing but the radius is 1 unit. And suppose if I go for center of that circle is the origin of the coordinate axis. So if you say this is y dash and this is y, this is x dash, and this becomes x, and this is the origin. Now the radius, here we have taken the radius of the circle is 1 unit, so that it is considered as a unit circle. Take a point P on the circumference of the circle whose coordinates I want to take as AB. What is A? Suppose if you drop perpendicular and if you say this is, and if you say, and this is nothing but A, this is nothing but A, and that x coordinate distance from the x axis, y axis, and y coordinate distance from the x axis, so this is nothing but B. So look, this is B, and this is perpendicular, and you know this is the radius, this is also 1 unit, radius is 1 unit. Now we go for that PB, any point, what you say, P, A, B, B, any point on the circumference of a unit circle whose center is at the origin. Shortcut. PB, any point on the circumference of a unit circle whose center is at the origin. Now you have to say, let this what do you say, suppose this is A, this is B, this is C, this is D. You say that AOP, this is taken as x radians, and here you see, let that angle AOP is x radians, positive radians, and we define, look, this is very understanding point here, we define 6 trigonometric functions. What we define? We define that coordinates. What is this? We define A is equal to cos x and B is equal to sin x. Try to understand. A is equal to cos x and B is equal to sin x. So that is divided by hypotenuse as 1, and ultimately you are understanding that B by A is tan x. See, B by A means sin x by cos x, and A by B is cot x. Similarly, you know that 1 upon A is sec x and 1 upon B is cosec x. So these are the trigonometric functions we have taken here to define. I hope you understood that how trigonometric functions are defined. Now I want to define that trigonometrical identities, how we are going to see. See, that is in a right angled triangle. In a right angled triangle OMP. OMP. This is a right angled triangle. In this right angled triangle, that you know, A square plus B square is equal to 1, because Pythagoras theorem, no? OM square plus MC square is equal to 1. So what I say that, what is A? A already we have defined. A is cos x, B is sin x. So this gives that cos square x plus sin square x is equal to 1. Therefore, sin square x plus cos square x is equal to 1. This is equation number 1 you have got. Now try to understand, this is the first identity you have got it. Now what I say, divide equation 1 by cos square x. This equation number 1 by cos square x. What? Sin square by cos square x. Then what we get? We get tan square x plus 1 is equal to 1 by cos square means secant square x. Therefore, secant square x is equal to 1 plus tan square x. This is the second identity you got. Now again you say, divide equation 1 by, this time sin square x you do. So divide 1 is this, sin square x by sin square x is, we get what? We get 1 plus, and cos square x by sin square x is cot square x. So 1 by sin square x is cosec square x. So what is the formula you have got? Cosec square x is equal to 1 plus cot square x. This is the third identity. This is the way how we have proved the basic identities. One is sin square x plus cos square x is equal to 1. Second is secant square x is equal to 1 plus tan square. Third one is cosec square x is equal to 1 plus cot square x. This is the way how we have defined trigonometric functions and the basic identities. Now I am going to discuss that regarding that angles I am discussing. I hope you understood all this. Now coming to the quadrant angles I am explaining. What do you mean by quadrant angle? Angles are called quadrant angles. Which angles are called quadrant angles? That I want to tell first. And later on you have to tell that how we take the results of this. And basically, when you understand that quadrant angles are those, see here, quadrant angles. Quadrant angles means the angles which are multiple of pi by 2. See, the angles which are what? Multiples of pi by 2. They are called halide angles. I want to tell you one, again I have to consider one unit circle, and you have to see that x-axis and y-axis. This is origin, this is x, this is y, and x dash, and this becomes y dash. You know, this is A, B, C, D. And when it is a unit circle, A has the coordinates 1, 0, this also 1, B has the coordinates 0, 1, and C has the coordinates -1, 0, and D has the coordinate, here you have to see 0, -1. Now I say that particularly when you are taking the result, suppose as usual, if you take this P is the point AB, you see this again, and this becomes A, and this becomes 1, and this is 1, and you try to understand this becomes X. That already I have shown you. Now we are going to discuss trigonometric functions of quadrant angles. And which are the quadrant angles? The angles which are multiples of 90 degree. For example, 0 is because it is multiplied pi by 2, and even pi, 3 pi by 2, 2 pi, these are called now, right now, we call these are the quadrant angles. Now we are going to discuss about that how we understand the trigonometric functions of quadrant angles, and accordingly you have to see the results here. But when you see that, the 5 points I am going to discuss here. Suppose that when P is here, the angle is X. When P is at A, see, if P lies at A 1, 0, then what is the angle? Then X is equal to 0. Yes. Suppose if P is at A, then what? X is equal to 0. Then you know this implies that already first one is what? That cos, see, and here we have to tell the value of A equal to 1. This implies A equal to 1 and B is equal to 0. A means what? Cos 0 is equal to 1 and B andre sin 0 equal to 0. So try to understand that how we write A equal to 0, B equal to 1, cos 0 equal to. So here you understand the same way that if P lies at B 0, 1, what is the value of then what is the value of X? X is 90. If P is here, you take the angle is 90, then what happens here? This implies A equal to 0 and B equal to 1. What is A? Cos pi by 2 is equal to 0. And try to understand sin pi by 2 is equal to 1. Similarly, even if you go far, if P lies on C, C means -1, 0, then what is the value of X? Then X is equal to pi. So here you have to understand that accordingly the definition, this implies what is A? A is equal to -1 and B is equal to 0. What is A? A means cos X. X is how much? Cos pi is equal to -1 and sine pi is equal to 0. Now you go for, suppose if P lies on D, what are the coordinates? 0, 1, 0 minus 1, and what is the angle here you have to tell? Then x is equal to 3 pi by 2, 270 degree. Then what? You see, A is equal to 0, B is equal to minus 1. What is A? Cos 3 pi by 2 is equal to 0, and sine 3 pi by 2 is equal to minus 1. Now likewise you go for once again that point P lies. One more way I am going to explain here. Next, what I write? If P lies at A 1, 1, 0, then one complete, then x is equal to 2 pi. Suppose you go A, B, C, D, again A, one round, then what is the value of x is 2 pi. And here what comes? A equal to 1 and B is equal to 0. What is A? Cos of 2 pi is equal to 1 and sine of 2 pi is equal to 0. So these are called trigonometric functions of quadrant angles. These values you have to remember, and it helps a lot while working all these results. So when you understand all these points, and basically in general that I have to go for, and accordingly you have to explain the things. See, when you observe all these, you will come to conclusion, one conclusion, that in general. See that in general. For example, in general, look this, in general, when you see that sin x is equal to 0, if x is equal to, sin x is equal to 0, you have to see sin x is equal to 0, observe, sin x equal to, here x equal to 0, where again 0, here 0, pi, and again, so 0, pi, 2 pi. What is this? It is the, what you call that, integral multiple of pi, that is called n pi. See, x is equal to n pi. If x is equal to 0, 1 pi, 2 pi, 3 pi, you will get it sin x is equal to 0. Try to understand here, if x is equal to n pi, and you will get it 0. And here you will understand that when you go for writing what is the value of n, any integer you have to take, n belongs to z. And similarly, when you see that cos x is equal to 0, if cos x is equal to 0, you check it. Here 90, 0, here is not 0, here 90, again 3 pi by 2, and you see that 93 pi, 9 by 2, 3 pi by 2, see 1 pi by 2, 3 pi by 2, odd multiple of pi by 2. If you say that x is odd multiple 2n plus 1, bracket complete pi by 2. So what is, how you say odd multiple? N equal to 1, it is 3, n equal to 0, it is 1. So cos x is equal to 0, x is odd multiple of pi by 2. These are the conditions that when x is equal to 0 and cos x is equal to 0. Now we may define trigonometric functions in terms of sine and cosine only, because sine and cosine are basic trigonometric functions. So we define what? How we define? For example, that first you see that tan x. Tan x is what? Sin x by cos x. And here we are, that is x is not equal to 2n plus 1 bracket complete pi by 2. And why it is so? Because if it is odd multiple, this becomes 0. If this becomes 0, denominator is 0. If denominator is 0, it is not defining. Even you say cot x is equal to cos x by sin x. And here x is, sin x is there, not n pi. Try to understand, when it is n pi, you see that what happens? It becomes 0. Denominator 0, not possible. Suppose if you say cosec x is equal to 1 upon sine x. What is x is not equal to n pi. Why you are writing n not n pi? If n pi, again it is 0. Similarly, sec x is equal to 1 upon cos x, and x is not equal to odd multiple of pi by 2. So these are the possibilities. We explain that 4 trigonometric functions only in terms of sine and cos. This is a way how we go for understanding the trigonometric functions in sine and cos. Now coming to the next, generally when you go for understanding the results, so here I tell you some important table with the quadrant angles that I am explaining. So in the previous standard, you know that well-known angles 0, 30, 60, 45 and 90. Now I want to discuss the results in this fashion. Now I have to tell sine, cos and tan. First one is 0 and 0 here. 30 means 5 by 6 and 5 by 4, and even you say 5 by 6, 3, and this you see this 60 and 90, and even 180 and 3 5 by 2, even you see 2 5. See, these are the possibilities. The table is to be prepared. How to prepare this I am telling you now, because you must know how to remember these values. So similarly, I have to tell that how you can remember the results. So now, first of all, this is trigonometric, that is standard angles, and here I write sine, here I write cos, and here I write tan. That is, you have to write all the tables. Trigonometric functions I write. Trigonometric functions. First of all, sine you have to prepare, and really here you have to see this cos is to be prepared, and tan is to be prepared. So how to prepare this table I am telling you. You know that according to the previous standard, sine 0 is 0, sine 30 is 1 upon 2, sine 45 is 1 upon root 2, sine 60 is root 3, sine 90 is, and cos sine 90 is 1. Now for the cos you have to go for reverse. That 1 root 3, 1 by root 2, 1 by 2, this is. And tan is sine by cos. 0 by 1 is 0, 1 by 2 divided by, see this result, you have to see that how you can go for it. And this is root 3 by 2, and this is 1, and you have to see this how this can be taken, and accordingly tan 60 you have to write. And you see that tan 60 is how much? Tan 30, that 1 upon 2. Here you have to see this cos 30 is root 3 by 2. And here sine 60 is root 3 by 2. So here you understand that 1 by 2 divided by root 2 by 1 is here, tan 45 is one answer. And here you have to tell that 1 upon 2, 2 upon 3, this is 1 upon root 3. And here you have to tell that 1 upon root 3, 1 upon, see 1 upon root 3 upon 2, 2 upon. So you can see this root 3. And 1 by 0 is not defined. What do you say? Not defined. So accordingly the results, when you say that point, when you are going to consider. But important is this, how to fill up this. Already I have told you that easiest way you can do this when you see these quadrant angles. A, B, C, D, 1, 0, 0, 1, minus 1, 0, and 0 minus 1. This is possibilities you have to remember. Now first I have to tell that instead of pi by 2 you go for pi. Sine pi means you have to see this angle is pi, and you have to tell that when cos pi, sine pi, first sine pi is 0 and cos pi is minus 1. First cos, and when you go for this result 3 pi by 2, 3 pi by 2 here, cos 0, here you have to see this, what is the value of cos 3 pi by 2? Cos, here it comes 3 pi by 2 and here pi, and cos 3 pi by 2 is 0, cos 3 pi by 2 is 0, sin 3 by 2 is minus 1. And when you are going to see this 2 pi and cos 2 pi is 1, cos 2 pi is 1 and sin 2 pi is 0. So now coming to 0 by minus 1 is here, you have to see that 0 by minus 1 is, and minus 1 by 0 not defined, and here you see 0 by 1 is 0. So now we go for finding the results of this and can be verified. So you see that when I go for taking that 0 and not defined 0, 0 and minus 1, 0, 1, 0, minus 1, 0. This is the way how we go for finding the table with quadrant angles. This is a actual fact how to remember how to fill the table here. Now after completion of this, now I am going to see that sine of trigonometric function, that is very important. What I say, sine of trigonometric functions. So we see that there are 4 quadrants, first, second, third, 4. In all quadrants, what is the sine of trigonometric function? All trigonometrical functions that we discuss, and how you can see that trigonometrical values, and accordingly we can see the result now. So first I want to discuss that sine of what? Trigonometric functions. Trigonometric functions. First to understand how I am explaining this, very important. So like that you go for a unit circle, that already I told you, and quadrants, that already defined, y dash and x dash, y, and here x, take a point here, p, eb you take, and you see this, already this point is x. Suppose if you continue, suppose q, and here you have to write a minus b, and here you see this, and this is nothing but minus x, a 1 0 and b 0 1, c minus 1 0 and d 0 minus 1. These are the possibilities that you can understand how sine can be explained, and you have to see that when you go for understanding that PB any point on the circumference of a unit circle, and thereby you can see this point is m you have taken. But when you go for studying this and the angles, so PB any point on the circumference of a unit circle whose center at the origin, let that angle you have to see AOP, angle AOP is x, and one more angle AOQ, angle AOQ, this is minus x. Now we have to go for studying that how we see the results of all these, and accordingly we can understand the results. And you know that Q is the point on the circumference of a circle of units radius, whereas but Q has the coordinates A minus B. Why? Because OM is A, whereas MQ is minus B. And see, when you consider, you have to see Q A minus B on the circle, and you have to say on the circumference of a circle, you have to see and try to understand. You can say that A is equal to 1. See, A is equal to 1 when you see this angle, and that angle, what you say, MOQ, MOQ, AOQ or MOQ, whatever you say, AOQ is equal to minus x. So what is this coordinate A? This is, you have to tell that here particularly that cos of minus x is equal to A, and sine of minus x is equal to minus B. Yes, you have to tell that this angle is cos of minus x is equal to A, and sine of minus x is equal to B. And you see this cos of minus x equal to A is nothing but what? A is, you have to tell that cos x, and sine of minus x, what is B? B is minus sine x. So try to understand, cos of minus x is equal to plus cos x, sine of minus x is equal to minus sine x. So here you understand the value of A is always lies between plus and minus 1, and even the value of B is lies between minus 1 and plus 1. That is why the value of A means cos x is lies between plus and minus 1, and even the value of sin x lies between minus 1 and plus 1. This is the way how we understand the quadrant rules, and accordingly you can see the results. Now we have to go for taking P is any point. If you go for taking all the way around, you see that when sine is positive and when sine is negative. Look, let P be any point on the circumference of a unit circle. If you say P is any point on the, you see this is a P into AB is any point on the circumference of a unit circle, and here you can say the point is as per the things here. Suppose, as we know that, see, 4 quadrants I understand, as we know that. So what is the first quadrant? First quadrant is here to here. Here it means 0 to 90. 0 to 90 is the first quadrant. So here you understand that in the first quadrant, as you know that, see, in the first quadrant, see, in the first quadrant, what is the first quadrant? You can say in the bracket, first quadrant is x is greater than or equal to 0, is lesser than or equal to pi by 2. Yes, correct or not? That x is greater than or equal to 0 and lesser than or equal to pi by 2, and accordingly you can see that. But quadrant is strictly speaking that here x is greater than, so 0 to pi by 2 is that quadrant x is greater than 0 and lesser than pi by 2. It is the first quadrant that you can say. When you see this first quadrant, and you can see that in the first quadrant A, and here you see that A is positive or negative in the first quadrant, and here A is positive and B is also positive. See, in the first quadrant this is also positive and this is also positive, and A is also positive and B is also positive, and so you can say that A means what? This implies what do you say? Cos x is positive and sin x is positive. So what I say that in the, this implies both are positive. So in the first quadrant both are positive. You try to understand. So how you say that both are positive? A and B in the first quadrant both are positive, and hence it is both are negative. So here when you go for the second quadrant, see when I go for second quadrant, and accordingly I have to tell. See second, as we know that in the second quadrant means here to here, means pi by 2 to 5. Yes, this is a second quadrant. In second quadrant, you see that A is negative, A is negative, and B is positive. So what do you say this? A means cos x is negative, and sin x is positive. Sin x is positive. Try to understand that cos x is negative and sin x is positive. Accordingly, the definitions that you can say. And when you see this case, similarly for others, that is going for third one, if you say, in the third quadrant, look this, in the third quadrant, what happens? You see, in the third quadrant means here, pi, you see, pi is less than, x is less than 3 pi by 2 up to here. And here what happens, when you take here, and you see this is also negative, and see A is negative and B is negative. So here you have to tell that cos x is negative and sin x is negative. So this implies tan x is what? Positive, because negative by negative is positive. So here you have understood that how the functions are negative. Similarly, in the fourth quadrant, you see that what happens in the fourth quadrant. Fourth quadrant, what is negative? Fourth quadrant means 3 by 2 is the least, and here you have to tell this is the fourth quadrant, here to here. And here what you say this, that particularly when you take in the fourth quadrant, A is positive and B is negative. A means what? Cos x is positive and sin x is negative. Where? In the fourth quadrant. Similarly, you can understand that how positive, negative, that you can get it. So now, in all together, combined way, how to remember these trigonometric functions, positive or negative, in the respective quadrants. So for that, I want to tell one shortcut method. See, when you go for this is the first quadrant, second, third, and this is fourth. Suppose if you go for like this, and already I told you in the first quadrant, see, first, second, third, fourth. In the first quadrant, you see, all are positive. All are positive. In the second quadrant, only that sine is positive. Sine and its reciprocal ಯಾವುದು cosec is positive, remaining negative. In the third quadrant, see, tan is positive. Tan is positive and cot is positive, it's a reciprocal, and remaining negative. In the fourth quadrant, what is positive? That particularly when you go for, we have studied that A is positive and B is negative. And you see that cos x is positive and reciprocal sec x is positive and remaining negative. So what I say that all, I say, silver tea cups I write. You have to remember this word. All silver tea cups. A means all are positive in the first quadrant. Yes, in the second quadrant, yes, sine and its reciprocal cosec are positive, remaining all are negative. T, tan and its reciprocal cot are positive, remaining are negative. C, cos and its reciprocal sec are positive and remaining all are negative. So remember the word all silver tea cups, and that also you can see attend, what do you say, all students take copy also. So anyhow, in general, we use all silver tea cups. That is the word, that is the phrase which gives the sign of trigonometric functions. I hope you understood that, how we understand the trigonometric functions, when positive, when negative, why positive, how to remember. All these things I told, and accordingly you have to remember. So basically one more point is to consider that, particularly that quadrant angles. Quadrant angles. And now you have to tell that quadrant angles means multiple of 90. Now I am to tell that as we have studied in relations and function, that domain and range. There are 6 trigonometric functions, and you must be able to tell domain of all trigonometric functions and range of all trigonometric functions. So what is the domain? Domain means that is that values of x. That I say that domain means that is the input, because sin x, cos x, tan x, whatever you are telling, and whatever the input you are giving, any value you can give, x, any value, x equal to any value means any real number you can put. So you will get the sine value, cos value, like that. That input values are called the values in the domain. And output, what we get it, sin x, cot x, all trigonometry x, that is output value is called range. So let us understand each function you have to go for. For example, sin x, and what are its inputs? You go for a set of all real numbers. And what are the outputs? You will get it sine, whatever the angle you will get, maximum is +1 and minimum is -1. So the range is -1 to +1. Likewise, for the cos function, that domain is, and that also lies between -1 and +1, that already I told you, and domain is -1 to +1. And what is the range? And that you can see what is the maximum and minimum. So here you have to see that 0 to pi, because cos 0 is 1 and cos pi is -1. Minus, see, you have to go for 1 and -1, you know, the values of cos x lies between. So 0 to pi is the what? Range of the cosine function. Likewise, we go for writing the domain and range of tan, cosec, sec, cot. So once again you see, domain values means input values, and range values means output values for the trigonometric functions. So, but here I want to give that some one table, and accordingly you can see. So trigonometric function, and I have to write that one is only two values, you know, one is domain and the other one is range. So try to understand how many trigonometric functions are there. 6, all 6 you have to write, you know, that to sine, because you have to take x, y, or anything else. Usually x and theta we take, sin x, cos x, tan x, and you can see this cosec x, and sec x, and cot x. So you have to write the all these values, domain and range, and accordingly you can follow the results. See that how you can write all these values here. So basically that domain values are input values, range values are output values. Whatever the values you are giving input to the trigonometric functions, and those values in the domain. After putting, we'll get the result, output, and those values are belonging to the range. So already I told you, when you take that sin x, and what are the input, whatever the value you have to put it, that to set up any number. So better you go for writing R. R is the set of real number. Those are input values for the cosine x, and for that, what is the output? Maximum -1 and minimum -1, maximum +1. So you will get it this. This is the range that you can say -1 to +1. Similarly, cos x, this is also any value real number, and here also we'll get it. See the range when you get it, and accordingly you have to find out the result. So what is the here? -1 and +1 only. -1 and +1. See this, when you go for the output results, you can write it, whatever the angle you can say. And one thing you remember, cosine is also lies between -1 and +1. Sine is also lies between -1 and +1 for the input values of any real numbers you take it. And now, when you go for tan, tan means what you say, sine by cos. And when cos should not be 0 is nothing but x is not odd multiple of pi by 2. So here you have to go for restriction that x should not be odd multiple of pi by 2, and accordingly you can see the result. So you have to see the result, any value x such that you have to see x should not be equal to 2n plus 1 pi by 2, that n belongs to that. So all values of x except this, and that is the what domain of the tan function. And here you get it, tan values minus infinity to plus infinity, and that is nothing but what set of real numbers, minus infinity to plus infinity. And similarly, for you see that cosec means 1 upon sine. 1 upon sine. Sine means when sine is not equal to 0, x is not equal to n pi, and this is the case. And this cosec x, you see that 1 by sine, that is why you have to take all values of x except n pi, that you can consider for the cosec x. And here you have to tell -1, and here the two values -1 to minus infinity union, and here you have to tell +1 to infinity. So -1 closed bracket, +1 and infinity is open bracket, and that is the range of the functions that you can say. For a cosec x, here also it is same thing, x such that 1 by cos, here cos means should not be 0 for what? Odd multiple of 2n plus 1 pi by 2, n belongs to z, and here also you can see the same result, minus infinity to -1, this is closed, open, union, closed, this is open. And cot means you know, cos by sine, and here you have to tell that denominator sine, and here you can see x such that x is not equal to n pi, because denominator sign is there, n belongs to z. So try to understand, here also we will get it on the any values, and that is possible for the cortex. So now you can understand that how we go for finding domain and range of the all trigonometric functions that you can understand. Now coming to the last point, I am going to explain that how to draw the graph of all these 6 functions, and here I am giving you only one, and for that you can go for other 5 trigonometric functions. So in the examination, if they ask only sine, they ask, you can draw, but I give you the idea of how to draw the graph of all these functions. Once again, you understand how to write the domain and range of the trigonometric functions. So, graph of sin x. First, I want to discuss that graph of sin x. So, first one is, you see, graph of sin x, I am explaining. Like that, graph of cos x and tan x, sec x, cosec x, cot x. Look this, I have to tell this is x-axis, this is y-axis. No, this is x-axis, you see, this is x dash by x-axis, and this is y, and this is y dash, this is 0. Now, x values means set of real numbers you have to take. Any values you have to take. For example, I say that 1, you have to see this x pi by 2. Next pi by 2 means it is pi. Next pi 2 means it is 3 pi by 2. Next pi by 2 means it is 2 pi. And in the same way, you can see 1, you see that minus pi by 2, and this is minus pi, and this is what, minus pi, minus 3 pi by 2, and even you can extend, you see this, the same result, minus 2 pi. So these are the values of x that you can write. And what is the value of y? Y equal to sin x. That range value is plus 1 and minus 1. You see this 2 I want to take. See, and here I take, this is 1. This value is 1. And same way, you can go for taking this, and this is minus 1. Now you have to plot the points and draw the graph of this. Why I have taken minus 1? Because sin is lies between minus 1 and plus only. But here, set of real numbers. So when you go for sin 0 is 0. And you tell me that sin 90 is 1. That is pi by 2, 1 here is, this is. And you have to go for that once again, that sin phi is, see sin phi is how much. If you get confusion, then you try to understand how you get it 0. So already I told you that if you don't know, if you go for A, B, C, D, 1, 0, and 0, 0, 1, minus 1, 0, and here 0, minus 1. So when you go for 2 pi, pi is here, and here you have to tell that sin 0 is 0, and here. And even sin 3 pi by 2, sin 3 pi by 2 here, it comes minus 1. See this? It comes minus 1. And you see that 2 pi here, sin 2 pi is 0. So how you have got this? The graph this side, it goes up 1 and down here, and here it comes, and here it goes. And similarly, you go for that if it is 1 line is going to draw it, this is 1. In the same way, we can go for the left side. What is the left side? Left side. And similarly at minus 1, you go for this is, and here also you can see this. And now you go for taking here sin 90 is minus 1 and sin minus 5 is 0. And again sin minus 3 pi by 2 is minus 1, it goes, and again it comes. So what happens here? This is the sine wave, and in physics this is called a sinusoidal wave, you can tell, sine wave. And here you can tell particularly domain is set of real number, and range is, you try to understand that already I have told you, minus 1 to plus 1. So domain is this all set of real numbers. Range is minus 1 and plus 1. The value of sin x and is the real values between minus 1 and plus 1. This is how we go for explaining that graph of sine function. Similarly, we go for drawing the graph of sine function and tan function, cot function, cosec. But these graphs even help us to write the domain and range of respective functions. So once again I tell you, maximum extent they may ask, draw the graph of the function sin x. You have to consider let y equal to sin x. Likewise, you can continue that graph of y equal to cos x, y equal to tan x, y equal to cosec x, y equal to cot x. But here, for the examination point of view, to draw the graph is sine function is important, that already I have shown. But the rest 5 functions, I send you the notes how the graph to be drawn, but you try accordingly. When you are writing the trigonometric function, and thereby I suppose to tell, write the domain and the range of the function. So I hope that you have understood how to draw the graphs of trigonometric function. Now, at the end, in this class, you have understood that how we have defined the 6 trigonometric functions, and here also we have understood the basic identities, and also we have understood that quadrant angles and well-known angles, and also the sign of the trigonometric functions, domain and range of the function, and finally that we have done how to draw the graph of the function y equal to sin x. Thank you.